Hello everyone, welcome back to the channel. I hope you are all doing well. Today we are going to learn about one of the most important topics in modern search systems, lexical search versus semantic search. So whenever we search for something on Google, Amazon and Netflix or even in Elasticsearch, we expect to get the most relevant results within seconds, right? But have you ever wondered how a search engine decide which document to show? So, does it simply match the words we type or does it actually understand what we are going to try? So, the answer is depends on the type of search being used. So, there are two major approaches, lexical search, which focus on exact keywords, and semantic search, which focus on understanding the meaning behind the query. So, in this session, we will understand both approaches, compare their strengths and weakness, look at the real world use case, and finally see how they are implemented in Elasticsearch. So, I will explain everything in simple language with practical examples. So, even you are new to this topic, don't worry, you will be able to understand it very easy. So, let's begin. Okay, so let's start with lexical search. Lexical search is also known as full text search. It finds matching documents by searching for exact words, token, or stem variants specified in the user's query. To understand this better, let's take an example like you are shopping online. You search for wireless headphones. The search engine starts looking for documents that contain those exact words. If a product description contains wireless and headphones, it will likely appear in the search results. However, if another product uses words like Bluetooth headset instead, lexical search may not consider it relevant because the exact words are different here. So this shows us one important thing. Lexical search focus on match words, not understanding the meaning. Now let's understand the three main concepts that make lexical search work efficiently. So first one is inverted index. An index create a mapping between every unique words and the documents in which that words appear. Like think about the index page at the end of the textbook. If you want to study a particular topic, you don't read the entire book, but you simply look at the index, find the topics, and tells you exactly which page contains the information. So here Elasticsearch follows the same idea. Instead of scanning every document whenever someone performs a search, it directly checks the inverted index to identify which documents contain the requested words. This makes searches extremely fast even when millions of documents are stored. BM25 algorithm, which is also known as best match 25. In this, finding documents is only the first step. Now the search engine has to decide which document should appear first. This is where the BM25 algorithms comes in. Here, BM25 calculates a relevance score for every matching documents using two important concepts. The first is term frequency or TF. Like in here, this simplify checks how many times a search terms appears in a document. Like if a document contains the keyword several times, there's a good chance that document is closely related to the user's search. And in here, second is inverse document frequency or IDF. Some words like the, is, or, and appear in almost every document, so they don't help much in determining relevance. On the other hand, words like Elasticsearch, Docker, or Kubernetes appear less frequently, making them much more valuable for ranking. So here, BM25 combines both of these factors and gives each document a relevance score. Documents with higher score appears at the top of the search results. Verbatim precision. Here, it's a major strength for lexical search in verbatim precision. It is excellent at matching exact strings, number, error codes, and alphanumeric in SKUs. Like for example, we are taking if someone searches for an error code like HTTP 404 or a product ID, user expect to see documents containing those exact values. Lexical search perform well in these situations because it focuses on exact text matching. That's why it is widely used for log analysis, product catalog searches, legal documents, inventory system, and system diagnostics. So if your application require highly accurate keyword matching, lexical search is usually the best choice. Okay, now let's understand semantic search. Semantic search captures conceptual meaning and user intent by converting both the user's query and the document text into high dimensional numerical vectors. In simple words, instead of matching exact word, it tries to understand what the user actually means. And here the first concept is dense vector embeddings. Here, deep learning models convert text into mathematical vectors. These vectors represent the meaning of the text instead of just the words. Like, for example, the sentence I want to buy a laptop and I am looking for a notebook computer uses different words, but their meanings are almost the same. Their vectors will be very close to each other, and in the another concept it is KNN search, which stand for K nearest neighbors. It calculates the distance between vectors using similarity algorithms like cosine similarity or HNSW to find the closest matches. And the next concept is synonym understanding. Here, semantic search understands that different words can have the same meaning. This makes semantic search much smarter than traditional keyword based searching. Moving on to the next, let's look at some advantage of lexical search. Okay, so the first advantage is high speed and efficiency. Since lexical search uses inverted indices, it can retrieve results in some millisecond time, even when billions of documents are stored. It also uses very little CPU and memory. And second advantage is exact string precision. Lexical search is excellent at finding exact values like product SKUs, part numbers, log IDs, user IDs, and rare technical keywords. And here the final advantage is predictable and explainable. The BM25 scoring algorithm is deterministic, which means it produces consistent results. So, it is also very easy to debug, customize, and boost results based on specific document fields. Okay, now let's see why semantic search has become so popular. So, it is popular because it has different advantages. Like the first advantage is understand intent. Semantic search captures the full sentence, context, implicit meaning, and conversational queries without relying on exact wording. The second advantage is handles synonym gap. It removes the vocabulary mismatch problem by recognizing synonyms, slangs, typos, and different ways of writing the same thing. And the final advantage is multilingual capabilities. Cross-lingual embedding models allow searching across multiple languages using a single index. Okay, now let's compare both lexical search and semantic search side by side. Okay, so here in primary mechanism, lexical search uses an inverted index to match exact word tokens. But in semantic search, it uses dense vector in a high dimensional space. For query understanding, lexical search focus on exact words and terms frequency. Semantic search focuses on context, intent, and meaning. For example, searching cheap phone and budget smartphone may produce different results in lexical search, while semantic search understand that both have a similar meaning. And here for exact ID or code lookup, lexical search is excellent at finding exact SKUs, IDs, or log traces. Semantic search struggles with rare alphanumeric IDs. And for the vocabulary mismatch, here lexical search may fail if different wording is used, but not with the semantic search. Because semantic search automatically resolves this using vector similarity. Like if we take an example, for example, doctor and physicians have different words, but they have the same meaning. And for the resource cost, lexical search is lightweight and requires minimal CPU and RAM. But here in semantic search, It needs more resource because it uses machine learning models to generate embeddings. Okay, let's see where each search method is commonly used. Like for lexical use cases, lexical search is commonly used for log analytics, system diagnostics, e-commerce catalog searches using SKU or model numbers, legal document retrieval, and for exact same lookups. Like if we take for an example, searching for SKU 56789 or an error code like 404 is a perfect use case for our lexical search. And for semantic use case, semantic search is commonly used for customer support FAQs, conventional AI and RAG systems, natural language query engines, content recommendation systems. If we take an example, it would be like if a customer searches, how can I reset my password? The system can return an article titled, Forgot Your Password, because both have the same meaning. And in hybrid use cases, many modern search engines combine both approaches. This is called hybrid search because it provides the accuracy of exact keyword matching while also understanding the user's intent. Moving on to the next, here is the example like how we can implement lexical search by the steps. Like for this, first we use standard text indexing, then we use multi-match query, and third we use fuzziness and boost. For the implementation of semantic search, here we use dense vector mapping, embedding models, and KNN search query. And for the hybrid implementation, it combines the strength of both lexical and semantic search, and it uses parallel execution, reciprocal rank fusion, optimal accuracy. Moving on to the next slide. Now, let's look at some well-known companies that uses Elasticsearch in real-world application. Here, first is Netflix. Netflix uses Elasticsearch for real-time log monitoring, system analytics, and security event tracking because this helps them monitor their streaming platform and quickly identify any issues. Another one is Uber. Uber uses Elasticsearch to handle real-time marketplace metrics, driver-rider logging, and location data. This allows Uber to process huge amounts of live data efficiently. And for Slack, Slack uses Elasticsearch to provide instant full text message search across billions of conversations. So, when users search for an all message, they get result almost instantly. And for GitHub, GitHub uses Elasticsearch to index code repositories, issues, pull request, and commit history. This makes GitHub searching across large software projects much faster. And for the LinkedIn, LinkedIn use Elasticsearch for candidate discovery, profile indexing, and job recommendations. And it helps recruiters and job seekers quickly find relevant profiles and opportunities. And for the eBay, eBay uses Elasticsearch for product discovery, instant auto suggestions, and catalog search. This allows customers to quickly find products even in marketplace with millions of listings. Okay, so this was the complete overview of lexical search, semantic search, and hybrid search along with their advantage differences, use case, and basic implementation. In the next video, we'll implement all of these examples in Elasticsearch and see how they actually work in real time. We will create the queries, execute them, and understand the results step by step. So make sure you don't miss the next session. Thank you for learning with 8-Bit System Private Limited. I hope you found this session helpful and easy to understand. If you enjoyed this video, don't forget to like, share, and subscribe to the channel for more content. And if you have any questions or suggestions, feel free to leave them in the comment section. Thank you for watching, and I'll see you in the next video.